Can AI build a research-based PowerPoint for you? But what happens when we let an AI agent research, iterate, and improve it? And can we build the same thing with a deterministic workflow at a fraction of the cost? In this video, I test three different AI workflows to generate an electronics manufacturing presentation and compare both quality and cost. Let's start with the first approach, an agentic approach with iterations. In the first approach, I'm using an agentic workflow where the model can ask for permission before using external tools like this. The idea here is that instead of giving the model one large instruction and asking it to immediately create the presentation, the system can work through the task iteratively. Before building the PowerPoint, it first clarifies the important requirements. So here the model is not just generating slide text, it is being given the tools needed to actually perform the workflow, including research, data retrieval, and presentation generation. This is where the agentic approach becomes interesting. The model can make decisions about what information it needs and then use the available tools to build the presentation. The goal is to move from simply asking an LLM to write a PowerPoint towards an actual AI presentation generation workflow. The model can identify areas that need improvement and refine the presentation. So this approach gives us more flexibility and more opportunity for refinement. But there is a trade-off. Every additional iteration consumes more tokens and increase the cost. And in this run, the total cost was approximately 80 to 90 cents. Let's look at the second approach using desktop agent with deterministic workflow. This time, the workflow is much more deterministic. The model has predefined steps for planning, research, analysis, and PowerPoint generation. First, the model converts the user request into a presentation plan. So rather than asking the LLM to figure out everything from scratch, I'm essentially giving it an AI workflow architecture. Then the research stage retrieves the relevant information. This can include web research, government information, and structured datasets. The important difference here is that research is now a defined part of the workflow rather than something the model has to improve every time. The model can decide when additional research is required. If visualizations are required, the chart builder creates them. Then the PowerPoint builder generates the presentation. The workflow executes the generated Python file, and after permission is granted, the presentation is saved. And this approach is much cheaper. In this run, the cost was approximately 5 cents. That's a very large difference compared with the previous agentic workflow. The goal is to determine which parts actually need an LLM and which parts should be engineered into the workflow. Finally, let's look at the third approach, using ChatGPT with specialized tools. In this workflow, I already have specialized capabilities available for the task. The workflow starts with planning the presentation and defining the slide requirements. It can then access PIB data through a vector database, use MoSPI data, and use presentation building capabilities. So instead of asking the model to search for everything from scratch, it can retrieve relevant information from an existing knowledge base. It starts with planning, then calls different tools, then build PPT using base functions provided and improvised further. It's done. And this produced the strongest presentation of the three in the content quality assessment I conducted using an LLM. I'll show that comparison at the end. But that doesn't mean this is automatically the best architecture for every use case. The real question is what happens when we compare the three approaches on quality, cost, and the ability to improve the system further. So now let's put all three results side by side. The first approach, ChatGPT with the PIB and MoSPI tool, scored 91 out of 100 and had minimal additional cost. The iterative agentic workflow scored 78 but cost around 80 to 90 cents. And the deterministic workflow scored 74 while costing only about 5 cents. And this is the part I find most interesting. The deterministic workflow cost roughly 17 times less than the iterative agentic approach, while the content quality difference is only 4 points. So, at least in this experiment, the lesson is not simply that more AI calls produce better results. Good AI system design matters. If I improve the deterministic workflow, especially the research, validation, and quality control layers, I may be able to push that 74 much closer to the quality of the most expensive approach without dramatically increase the cost. That's the direction I'm exploring next. Better AI agents and workflows, not simply more LLM calls. If you found this comparison useful, consider subscribing for more experiments on AI agents, RAG automation, and data driven AI workflows. Thank you.